and then write ISN page 39 on the top right-hand corner. ISN page 39. Okay, so we're there. Now, what I have today is a PowerPoint again, and it is probably one of the last two that you will get from me. So I'm not a big fan. I like to write it myself, but I have these, and that way I'm not in the way. But I should have redone it, and I didn't. So when I first made it, I made way too much on one thing of notes. You had to write too small. So we're doing it on 2 different days and 2 different pieces of paper, but it's still kind of all in one thing. So you're basically going to ignore the right-hand side of the screen. It's going to be blank anyway, but it's just everything's going to come down the left-hand side. So with it closed, where you have ISN page 39 up here, then the top box is this box right here, and I want you to write distance in the coordinate plane, or distance on the coordinate plane. Yet, you can take up the whole box, just like it is up here. That's why the lines are there. Yesterday we talked about distance on the number line. So now we're looking at it two-dimensionally, and we're going to look at distance on the coordinate plane. Okay. The bottom box on the front is going to stay blank for right now. That's actually the last thing that we're going to write, is we're going to come back here and write it. So you should have distance in the coordinate plane, which is your title. Then you can open it up, and you have 4 boxes that we're going to write in, and we're going to start in the top left box. Okay. So this is the top left box, just like it looks on the screen. So I want you to write, find the distance between -4,7 and 1,5. And we're actually going to find the distance between those 2 points before we ever even talk about the distance formula, because we're going to come up with a distance formula ourselves. It is important that you understand how things work conceptually, like you understand the concept, and that you're not doing stuff just for the sake of doing it. So see, not the end of the world. You just, when you put it in your ISN, it's going to open this way. No big deal, right? So you just open it and then just do it. It's all good. All right. There are a lot of things that you do mathematically because your teacher said so. Like, why are you do this when you saw this? Well, that's what I was told to do. You don't really understand why. And when you don't understand the whys behind things, they don't stick with you as long. So when you understand where things come from and why, it really will help you a lot in the long run, because it's not just about just regurgitating a process, but it's understanding an overall concept. So in order to find the distance between these 2 points, we're going to start off by drawing a little x and y axis. So just a quick little, don't even use a straight edge. This is not a perfect thing. And do not ever again in your entire life waste even 1 second of your life making little hash marks on the graph. Because if your graph needs to look pretty, you need to do it on graph paper. Okay, if you're not doing it on graph paper, then it's a sketch, and it's okay that it's not accurate. All those thousands of little hash marks some of y'all try and put do nothing but make the graph look worse. Okay, so we're going to plot these points, but we're going to ballpark them. Like, they don't even have to be, I'm not counting anything because I didn't put any little hash marks on there. So 1,5 would be about, that looks good, 1,5. You're just getting something on the paper so that you have something to work with. It's okay that it's not perfect because we're not pulling the answer off the picture anyway. So -4,7, if I went to the right this much for 1, I got to go more than that for 4, and then I got to go up a little farther for 7, so about right there. Okay, just good enough. Yours doesn't have to look exactly like mine, but there's some things that shouldn't happen, like this one can't be lower than the first one or whatever, but you've gotten something. So then we're going to connect them. Put a D, because I want the distance between those 2 points. Can you legally, mathematically count diagonally on a graph to get a distance? And I said legally. You can do it, but you'll be wrong. You cannot count diagonally to get the distance. It doesn't work that way. Can you legally count vertically and horizontally? Yes. Okay, so we're going to draw in little dotted lines vertically and horizontally until they intersect there. And when I do that, what do we create? A triangle. Specifically what kind? A right triangle. Okay, so I've got a right triangle. I know it's a right triangle because it was vertical and horizontal lines. I mean, clearly it's not labeled that way, but it has to be because we were doing vertical and horizontal. All right, so I have enough information not to count diagonally, but I can count vertically and horizontally, or don't necessarily even have to count. I have no hash marks to count. Can I find the side lengths of the two side lengths of the triangle? Yes. What is this vertical one? 2. And what's the horizontal one? 5. Okay, so I've got 2 and 5. Right? Should be able to figure that out from the graph. Piece of cake. So I have 2 sides of the right triangle. Do you know how to find the missing side of a right triangle? Yeah. Yes, it's Pythagorean theorem. So what is the Pythagorean theorem as you know it? Okay. Very good. Now, but that is actually, there's words that go with the Pythagorean theorem, so that's technically not it, but but I'll take it. That's what I figured you'd say anyway. That's all you really need to know right now. So we're going to use Pythagorean theorem, which you should be able to do in your sleep. It's a piece of cake. It's old stuff. When you do this, is there, or does it matter which one is C? That's what I'm trying to get out of my mouth. Okay, yes. So think without speaking. How do you know which one is C? Think without speaking. I want to know how we know which side is C. So here's speaking. Natalie. How do I know which one is C? Hey, your name is not Natalie. Okay, the longest side. Do y'all agree that C is the longest side? Okay, but you don't have all 3 numbers, so how do you know which one's the longest side? That still doesn't tell me which one is C. All right? So how do I know which one is C? That is a true statement about it, but where's Servando? Oh, that's right. I got it. All right, Juan. Where's Juan? All right. So how do I know which one is C? Which angle? Very good. It's the hypotenuse, and the C is the hypotenuse, and it is opposite the right angle. That's how you know. Is it the longest side? Yes, but when you don't have all 3 numbers, you don't know which one's the biggest. Does that make sense? You cannot go by the way it looks. Absolutely cannot go by the way it looks because it looks like it's the longest or anything else. The other thing that I hear a lot is that it is the diagonal one. So say, okay, well then I can draw it like this. Now is it the diagonal one? No. So I know what you mean by that, and I know what you mean by the longest side, and it is the longest side. How do you know which one's the longest side? It's the one across from the right angle, so that's how you identify it. Good. All right, so does it matter which one's A and which one's B? No, it really doesn't. Once you get C, A and B, it can be either one. It doesn't really matter. So we have this. I know this stuff is easy, but remember, your first step is zero work. You just plug it in. You're just substituting. So I'm going to substitute 2 in for A, 5 in for B, D in for C. So it looks like this. Notice I replaced all 3 things in the Pythagorean theorem. Never leave an A, B, or a C in there. It should be replaced with something, a number, a variable, something else. How do you find the distance on a number line? Where are your notes from yesterday? Distance on a number line. That's how we did it. Okay? So 2 squared is 4. 5 squared is 25. So I've got 4 plus 25, which is D squared. D squared is 29. Do I really care about D squared? What am I looking for? D. Okay, so how do I undo a square? Square root. So D is the square root of 29. Is that a perfect square? No. So I got to try and simplify it because I don't want the decimal either. What are 2 numbers to multiply give you 29? It's prime. So it's just 1 and 29, and those don't count. So I can't do anything. It is simplified as much as I can, and D is the square root of 29. Now, that is your exact answer. That's how it needs to stay. But you also need to have some concept of the value. So the square root of 29 is between which 2 whole numbers? 5 and 6, because it's between the square root of 25 and the square root of 36. So it's 5 point something, right? And so that kind of verifies that, all right, it is the longest side. Because if I'd have gotten something that wasn't more than 5, then I did something wrong somewhere, because it does need to be the biggest number. Okay. Everybody good with all that? Pythagorean theorem should be old business, should be a piece of cake. But that is where the distance formula comes from. So in your bottom left box, the box right underneath this, I want you to write, we're going to find the distance between x1, y1 and x2, y2. That just means those are just 2 random points out there somewhere, any 2 points I could pick. So I'm going to draw a little x and y axis. Now, do I know exactly where x1, y1 is and x2, y2 is? No, because it could be anywhere. So I just chose 2 places. There's nothing special about what I chose. I was just trying to get something where we could actually draw something on our picture. So it's not like they always have to be here. But I've got x1, y1 here. Put x2, y2 there. Then connect them and put the D. D for distance. Here's what you have to remind yourself, because I hear the same things over and over again for years and years and years. And I hate it when we have all these variables and we don't just have numbers. It's actually easier when there's variables and not numbers because there's less you can do. Does it look yuckier? Yes, it looks yuckier. But you have to remind yourself that the steps are literally exactly the same. You do the exact same thing if you had a variable as if you would if you had a number in front of you. The steps do not change. And you can always relate it back to something. What would I do if it was just numbers? That kind of thing. So we did up here, we said, all right, well, I know I can't count diagonally, so I'm going to draw in my vertical and horizontal lines. Oh, I am going to use Pythagorean Theorem again. Vertical and horizontal lines. And then I need to figure out what to label these 2 things. So I want you to think, without speaking, about what I could put on this vertical side length right here, modeling what we did up there. So think, without speaking. Get somebody to help me out. Rebecca. This thing likes you. Rebecca, right? Yes. Don't look too thrilled to be caught on. All right. So what do you think I could put here? Just x, x, y. So where are you getting that from? Okay, so where did we get 2 from? How'd you get 2? The 7 and the 2. Okay, the 7 and the 5. Okay, so we subtracted those, right? And so this minus this gave me that. So what do I write here? Model that exact same thing. Is it just y? Okay, well, this is, say this, what is this? Minus, and then we simplified that to get, so what is this? y2, minus y sub 1. Can you simplify that? So what would that simplify to? You can't subtract the ones. The reason they are y sub 1 and y sub 2 is because they represent 2 completely different numbers. So it's like having a p and a q, right? And if I had p minus q, it's just p minus q. We can't do anything, right? But we don't have different variables here because they're both y values. That's why we put the little subscripts. Yep, and that's it. Okay, but do you see how it's literally the exact same thing? Like, it looks weirder. I know it's pushing you out of your comfort zone. But if this right here is 7 minus 5, but we can simplify it to 2. So this right here is just this y value minus that y value. It is y2 minus y1. That's all we can do. It is literally the exact same thing. Okay? So then I also need something on the horizontal side. And then what would I put there? On. What am I going to label this as? If I could put this y2 minus y1 here, what's this going to be? Good. This is going to be x2 minus x1. All right, does that make sense? Because that's how we got this. Although, here, if I do negative 4 minus 1, what does that give me? What's negative 4 minus 1? Negative 5. But this is 5. So what did we do to get 5? Absolute value. Notice we didn't write the absolute value signs here. There's a reason why we don't even need them. We'll talk about that in a minute. But yeah, just like we happen to get a positive 2 here. This actually gives me a negative 5, but you take the absolute value. All right, so everybody okay with how we got these 2 things? Yes? All right, now, after we did that up here, after we got the 2 and the 5, then we substituted the 3 labels on the sides of the triangle into the Pythagorean Theorem. We're going to do the exact same thing here, okay? We're going to use this one for A and this one for B, and this obviously has to be C, okay? So you should be able to take these and substitute them into the Pythagorean Theorem. Okay, so go. And for those of you that are still staring at me or just refuse to write anything down until I move on, That's one of the reasons why, one of the many reasons why. First step should be zero work. You plug it in. If you don't know how to substitute that in, I don't know how to help you with anything. Because all you do is literally replace it. Instead of the A, you write the value for A. Instead of the B, you write the value for B. All it is a substitution. So it should be x2 minus x1 squared, because that's what we replaced A. y2 minus y1 squared equals d squared. It doesn't matter which one is A and which one's B, but you need to, right now, use this one for A so that it's consistent in the end with what we're trying to get to. But, I mean, we would get the same thing in the end. It's just not going to match the actual formula, and I don't want that to confuse you. Most of the time, when you think you're stuck, you could get a step or two, sometimes 3 farther than you already did. Because y'all are really, really good at worrying like 3 steps ahead. Because your little brains work pretty quick. And so as you're working, you're thinking a few steps ahead, which is not necessarily a bad thing. But you see something that looks weird and freaks you out a little bit, and so you think, I don't know what to do with that, and I'm stuck. But see how you plug it in. You know how to substitute. It doesn't matter what it is. It can be a monkey and an elephant. So you put a monkey squared plus elephant squared. It doesn't have to make any sense to you, but you know how to substitute it. And then maybe now you're stuck, or maybe you'll be stuck the next step, but always get as far as you can, because you can usually get farther than you did before you think you're stuck. So here's some good news. The good news is we're not actually squaring what's in these parentheses. We don't need to. We don't want to. I'm not solving for x. I'm not solving for y. What are we solving for? D. So there's no need to do anything else with what's on the left. So we're just going to leave it what it is right now, okay? I've got to get D by itself. So to undo the squared, what do? Square root. So I want you to rewrite this just so that you don't get lost in your notes. So rewrite all that, and then just put a big square root sign over both sides. Okay. You haven't done any of this. Why not? No. You didn't do any of this either. No. It doesn't matter. Yeah. So you need to get caught up like real quick. Okay. So when I take the square root of both sides, the square root of d squared, what's the square root of d squared? D. Okay. Over here, does the square root knock off these squares right here? 100% absolutely not. No way. Okay. So if I have the square root of 4x squared, that does give me 2x, because I can make that into the square root of 4 times the square root of x squared, because I can split that up. If I have the square root of 4 plus x squared, that absolutely does not equal 2 plus x. You don't get to take the square root of both things when you have addition or subtraction if you have more than one term. If it's all one term, yes, it works that way, but not this way. Think about this. If that was true, then if I have a squared plus b squared equals c squared, and I just take the square root of both sides, that would mean that a plus b equals c. Is that true? No, because if it was, why the heck would we square it and make our lives harder, right? So be careful. Do not be making up math. Nobody ever told you that doing this kind of thing was okay, all right, because it's not. And just because you're taking the square root and you see a squared sign, you don't get to just knock out the squared signs if you have more than one term in there. Does that make sense to you? Okay, so back over here. This does become D. Over here, the square root does not do anything to those squares. You actually can't simplify this anymore, okay, and that's okay, because see, we plugged it in. After we substituted this in, we can't even do anything else with it. Here, I had to actually square it, I had to add it, I had to take the square root and do all this other stuff. I can't even do anything over here. But I've got D, we're going to rewrite it, we're going to put D on the left. So the distance is equal to the square root of, and make sure you write all this down correctly, x2 minus x1 squared plus y2 minus y1 squared, just like that. So it looks yucky, right? It's got the 2's and the 1's, which shouldn't intimidate you too much anymore. But when you don't have a formula chart, this can get really kind of messed up sometimes. But here's the thing. If you understand the concept and where it came from, you can build it. It's different than memorizing it and trying to just put letters down on a page for some formula that doesn't even make any sense to you. If you understand that this came from the Pythagorean Theorem, and you know that, because I know y'all know that, all this is something squared, right, plus something squared. Because most people remember that there's a big old square root. The things that get messed up are the squareds get left off, and then the plus and minuses are all mixed up or lost. But see how this is something squared plus something squared. If you can get that, even if the parentheses are empty, then you know that this was your plus, so the minus goes inside, and you don't ever mix x and y, so you've got the x's together and the y's together, and you can build it from the understanding of the concept and not just memorizing some random stuff. Okay, does that make sense? Okay, you can check yourself. All right. And so that's your distance formula. All right, so top right box. I know this is the top left again, but put it on the top right. I want you to write this down. And then, who wants to read the first part of that to me? At least the first part of it. I'll say that. Go ahead. Yeah, very good. And you can stop there. So that is find the length of line segment AB, right? It's not find AB. It's not find points A and B like somebody wanted to tell me earlier. Last period, somebody said, find the distance between points A and B. Does that mean the same thing? Is that the length of the line segment, the distance between the endpoints? Yeah, that's fine. So, what we wrote down is find the length of line segment AB. Well, the length of line segment AB is the distance between A and B. So it's the same thing, just said differently, and that's fine. So the capital A and B, those are the names of the points, and then the coordinate of the points are stuck to them. So that's how you name points and write their coordinates. All right, so we're going to draw a little x and y axis, ballpark our points there, and get a little line segment drawn. So if you write, the first step that you should do, anytime you ever have a formula, in any course, in any class, whether it's math, whether it's science, no matter what level you're at, you should always write the formula down. It should be the first thing you do, even if you think you don't need to. If you actually write this down every single time you do it, you will know it when you're done. You haven't memorized it, you know it, right? If you came to school and you made new friends, right? Did you go home and make a list and memorize their names? No, because it's kind of weird, right? You know their names because it was a repetitive thing. You just know who they are and you see them, and that's how you know it. It's not a matter of, with your little list with the pictures. It'd be a little creepy, right? Okay. Yeah. Yes, you're the only one that does that. So that's the same thing here. It's not memorizing. You're learning it, and you will just know it, and it'll become second nature. All right, so the other thing that's helpful here, because the distance formula is not difficult, it gets messed up a lot because you get messed up on signs and other, just careless things, really, is if you label your points like you were taught for slope and stuff, x1, y1, x2, y2, it's a lot easier for you to plug things in and not do weird stuff. Then you just substitute it in. Okay, x2 minus x1 would be 4 minus a negative 5, and then 6 minus 7. And again, first step is zero work. You just plug it in. You're just substituting from the beginning. Then you have to be able to add and subtract positive and negative numbers correctly. So when you're getting distance formula wrong and you're getting frustrated, don't be hating on the distance formula because you're the one that's messing up on the signs. It's not the distance formula that's difficult. What's 4 minus a negative 5? 9. And then 6 minus 7, negative 1. All right, so I get the square root of 9 squared plus negative 1 squared. What's 9 squared? 81. And negative 1 squared is 1. Positive or negative? Positive. And that right there is why we didn't have to do the absolute value earlier. Because when you subtract them, even though I got a negative number, it's not really a negative distance, I'm going to square it anyway, and it just takes care of itself. So I'm going to get the square root of 81 plus 1, which is the square root of 82. Is that a perfect square? No. So I have to try and simplify it. So the square root of 82, 82, two numbers to multiply to give me that, or what? 2 and 41. So 2 is a prime number. 41 have any factors? No. 41's prime. So I've got 2 prime numbers. I have no pairs to take out. So it is the square root of 82, and that's my answer. Remember, that is your exact answer, right? It's not your Home Depot answer. You go into Home Depot and say, hey, I have this project, and I need a 2x4, and it's got to be the square root of 82 feet long. They're going to look at you like you're crazy, right? But if you go in there and you buy a 9-foot board, Are you going to have enough that for what you need, for whatever it is you need? No, because the square root of 82 is more than 9, right? If I bought a 10-foot board, would I be okay? Yeah, okay. So, well, yeah, but you can have them cut it, but at least you'd have enough. Yes, sir. We did simplify it during the tree. I just didn't write it down. It's 2 times 41, but those are 2 prime numbers. There are no pairs. You're done. Okay. So, last one. Write this down. I want you to work on this one. Do this one on your own while I pass out the homework and, yep, all the steps. I'm sorry, what? Distance formula, yes. Okay, so first things, we do this, we write down our distance formula. Might want to label your points x1, y1, x2, y2, because there were some people not plugging stuff in right, and it's never x1, x2, it's always xy, xy, okay? So when we plug them in, got this, so I did -5 minus 4. You could have done 4 minus -5. It's fine. All that's going to change is the sign inside the equal sign. Should get the square root of -9 squared plus -13 squared, or they might both be positive if you subtract it the other way. Because does it matter which one's x1, y1, and which one's x2, y2? It doesn't matter at all, so it's fine either way. Some of you are messing up on squaring 13. The front of your summer assignment was very clear that you need to know your perfect squares up to 25. You should be able to rattle them off. Otherwise, you are wasting your time. Because most of the people that went off to the side to do their 13 squared all day long today have been wrong. Like, you might think, oh, I can go figure it out. Yeah, but most of you aren't even figuring it out right, so that's not helping you. You should just know them like you do your multiplication facts, or that you should your multiplication facts. Clearly, some of you don't know those either. So this is the square root of 81 plus 169, which gives you the square root of 250. Now, is that a perfect square? It's not a perfect square. But it's one that you can simplify. This is one that you can easily see. If you end with a 0, you can take a 10 out easily. So we've got 10 times 25. 25 is a perfect square. 10 is not, but I can't just take the 25 out and just be done with it. I got to check the 10 because it's not a prime number. Because sometimes you'll take a perfect square out, but there's more stuff in there that you haven't simplified yet, and you can get yourself in trouble there. So the 10 is just 2 times 5. I can't take any other pairs out. Square root of 25 is 5, so I get 5 square root of 10. Now, if you're not at the point where you can do a shortcut like that yet, that is totally okay. You can do the whole tree, and that's fine. There's nothing wrong with that, but some of you might be to that point, okay? You could have, notice that that's your distance there. We could have made this into a right triangle. Here's where your 9 and 13 come from, right? That's this distance, that's this distance. So that's why Pythagorean theorem works. Now, on this homework, and on this, you need to do distance formula. I'm checking for that. And if you do not do distance formula, I'm going to count it wrong. Okay? But you can use Pythagorean theorem and get the same answer in the end. So once you're done with this, let's go back to the front. We left this bottom one blank. I want you to write the distance formula. Write it as big as you can right there. Make sure you can read your own handwriting. Make sure you write it down correctly. And then underneath that, you can use Pythagorean theorem instead. That means in general. Not on this homework, okay? On the homework, on the test, I'll be very specific about that. I want to see the distance formula because you do need to understand it for certain reasons. But just know it comes from the Pythagorean theorem. When all else fails, later on down the road, if you can understand how to make it in the Pythagorean theorem and get it, you're fine. Okay? Any questions about any of that? All right, once you get all that written down, then get this glued in. And you've got your homework on your table. You need to get started on that. Make sure you work until the bell rings.